Hey guys, and welcome to /Rex Games. Today I'm going to be showing you all about some helicopter mechanics, so the sort of top-down mechanics. I do apologize for not bringing this to you sooner. I just started a new job, so there were some things I had to get out of the way before I could get on to working with this and showing you all about it. So it's pretty simple. I'm going to click play over here. So here we go, we have a helicopter. You can see it's got its blades rotating there, and if I push enter, then it takes off. There we go, we can fly around. Notice inside the cockpit is our blue hero. Pretty cool, huh? So we can fly around. It points towards the mouse. Some code I'm sure you're familiar with by now. We've got a view going over here. Notice over here we've got a shadow. That's pretty cool. So at this point in time, this is a somewhat blank project. I've just got the sprites and the backgrounds all loaded in, but I don't have any objects. So we're going to create an object called object heli or something, and then I'm going to give it a whole bunch of code that's going to demonstrate to you how you can go about solving this whole mechanical system of a helicopter. So in our sprites here, we have sprite heli. It has 12 sum images. See, that's just the blades rotating pretty much. If we go into edit and we check the preview, see that over there. So basically it's going to be going about that fast. It depends how this screen capture software is picking up, but the blades are rotating really fast. So yeah, that's pretty much what we want to accomplish. Make sure that those are rotating while we're flying around. And then perhaps when we are landed, they are slightly slower. We'll figure that out as we go along. So yeah, there we go. I've drawn those, and they look pretty sweet. Okay, so as we can see, we centered over there. I've centered it on the middle of these rotational blades right over there. Okay. So, and then in our background, I've just got grass, and then I'm just tiling it throughout the entire room. You know, just using that as our background, and it's seamless, so that's really great. And I'm in our room right now. This is what it looks like. It's just this big old field. Big field, nothing happening. 4,000 by 4,000. There is a view. It's not following anyone right now. We'll sort that out as soon as our object is in existence. So let's go over here to objects. We're going to create an object called obj heli. Okay. We're going to give it our helicopter sprite. I'm going to add an event. This is going to be a create event. So I'm going to put some variables in here that I want to initialize when this helicopter is created, just so that this whole system works. So we're going to have something called max speed. Basically, you know, this is how fast we can go in any single direction. Then we've got our rot speed. This is basically our rotation speed. If you've seen any of my pointing towards the mouse, rotation, AI, any of those turret kind of tutorials, you notice that I do a smooth rotation story, and with that I need a rotation speed, speed at which it rotates per step. So in this case it's 8. Then I've got shadow. Shadow X and shadow Y. I'm going to set these to 100 by 100. This is how many pixels away from the helicopter the shadow is. So it's going to be 100 pixels square to the bottom right. 100 to the right and 100 down. See that? From the actual helicopter. Basically the shadow is just the exact same thing as the helicopter, but it's all black. So when it comes to drawing the shadow, you have several options. You could either make a whole other object and just have that object follow the helicopter at a certain distance away, or what you could do, as I'm doing here, I'm creating two variables, 100, 100 for the X and Y, and then in a draw event, I'm just going to draw our helicopter, all faded, but you know, with a black color, no detail. It's just going to be it's semi-transparent black shadow. It'll look pretty cool. So now we've got shadow X, shadow Y. The next thing we're going to do is state. Now state is just going to be a string that's going to store the current state of our helicopter. So in this case, we start as landed. Okay. Later on, we're going to add flying and takeoff and all that stuff. And then, depending on what state we're in, helicopter's behavior changes. And then I'm also going to do image X scale at a 0.5. Basically, when we landed, as we are here, we are half as big as this. See? So it's going to be half as big as that. That gives us a sense of distance between flying and the ground. The helicopter is, you know, a certain distance away from the ground. So when he has landed, he's going to be way smaller. Okay, so the next step, basically, we want to push a key, and it's going to change the state of the helicopter. So if we are landed, we push enter, and then we go into takeoff mode. If we are flying, we push enter, we go into landing. If we're landing, and we actually hit the ground, then it's going to change to landed. You know, all those kind of things. We want to change states by pushing enter. So let's make sure that is possible with a key press, and then enter. So over here, we're just going to have like a if-else sort of story. You know, if state equals landed, which we are now. If we're landed and we push enter, then state equals takeoff. Pretty simple. Else if you want to use a switch statement with holiday cases, you're free to do that. It all depends on what you feel like at the present time. So if our state is takeoff, right, so if we take it off when we push enter, then state is landing. Else if state is flying, so if we're flying and we push enter, obviously we're also going to be landing. So there we can land if we're taking off, and we can also land if we're flying. Else if state is landing, oh my, there we go, then state is takeoff. Pretty simple. So if we have landed and we push enter, then we're taking off. If we are taking off and we push enter, we're landing. So that's pretty much the opposite. See that? If we're flying and we push enter, then we're landing. If we are busy landing and we push enter, it means we are deciding not to land and we're taking off again. So basically that's going to handle the behaviors that follow right now. So now I'm going to create a step event, and right over here I'm going to create a switch. You could also do if else, but in this case let's do a switch. Switching on state. One of the cool things about GML is you can actually do a switch statement on strings, which is quite fun. Other languages are getting that too, which is pretty awesome. But in the past you could not do this with some other languages. So I always found this pretty cool and useful. So if the case is flying, let's start with that. That's good. Break. There we go. Case statement right over there. And we need one of these. So if we're flying, firstly, let's sort out where we are pointing towards. So point direction, make this bigger. Point direction of the X and Y of the helicopter is at mouse X and mouse Y. Oops. So now we're facing the mouse. That's our direction that we want to get to. Then obviously our image angle plus equals the sine of degrees to radians of the point direction, this one, minus the current image angle. Alright. And then here we're going to times rote speed. That's that 8. Rat speed. Rote speed. That's that 8 that we gave in the create event. That's our speed at which we rotate. So this will make sure that it's smooth and not instantaneous. We don't want things to be jagged. We want to simulate sort of like a real-world helicopter experience. It's going to slowly rotate to where it wants to go, as it's responding to what the pilot says. And then our image speed when flying, so this is the rate at which it changes a sprite. We can set that to 200. It's really fast. But that's how it works. Blades need to be moving really fast if we intend to fly. Okay, so now we're going to be doing some key press handling here. We're going to say, well, if keyboard check, I'm going to get the ordinates, let's see, W, so we always use W to go forward, keep things standardized. We've got enough brackets here. One more. So if we press W, it means we want to go forward. And what does forward mean? Well, basically, if speed, because we're using speed and direction here, so if speed is less than max speed, so as long as we can accelerate, speed plus equals 1. Speed of 1 per step, that's the increment right over there. Now, a cool thing that I'm going to show you here that I don't think I've really touched on any one of my other tutorials is friction. Basically, this is the rate at which something stops, slows down. So when we're flying, we don't want friction, so we're going to put this on 0. But later on, when no keys are being pressed, friction is going to be, for example, 1. Then whatever speed is, slowly it's going to slow down by that amount, and we come to a dead stop. It's pretty useful to use. Okay, so that is the W over here. Okay, so I'm going to say else. So if we're not pushing W, now we need to check, well, another F over here. Keyboard check. Oops. And in this case, we need to check the ordinate of an S. Put in a string there. Okay, so I want to say if we're not pushing S, so if we're not pushing W and we're not pushing S, obviously it means that now in this case we want friction to work, because we're not pushing any keys, which basically means go from a flying state at a certain speed and slowly but surely return to a hover state where we're covering no ground. Zero force is being exerted on our helicopter, so it needs to slow down. So obviously if speed is greater than 0, you could, if you wanted to, say speed like minus equals and then say 0.1 or something if you want. But in this case what I'm going to do is I'm going to set friction to 0.3. So that's going to do all that for us, and then I don't have to worry about messing with speed myself. Alright, so that's the W. So, if we're pushing W, if we're not pushing W, not pushing S, then we're going to slowly stop. So now we need to handle the, the reverse. So for keyboard check, again ORD, this is S, make sure we've got 3 brackets, open up some space over here. I'm going to say, well, if speed, so this is pretty much slowing down, is greater than negative max speed. Oh. Yes. Because when we're going in the negative direction, speed's going to change to a negative. Even though it's a negative speed, it's still a speed. It's just in the opposite direction. So if speed is greater than negative max speed, then here we're going to say speed minus equals 0.5. That's going to slow us down. Also friction. Friction is 0 because I'm taking control of the rate at which it slows down. I don't want friction messing with that too, so we make sure it's 0. And then I'm going to close this off. And I'm going to create an else over here. So if we're not pushing S, then very similar to the way we did this one, if we're not pushing W, change that to W, and if speed is less than 0, because it's all opposite, friction is 0.3. Right? So if keyboard is W, okay, so keyboard is not W and we are not pushing S. If keyboard is not S, see, we're doing nothing. It's again going to slowly go to the rest position, the hover position. So if we are going back, we're backing up with our chopper, and then we remove, well, we stop pressing any keys, it's going to slowly slow down until it's the hover position, exactly the same as it would if we are pressing W. So now that that's done, to finish off the, what's this? This is flying. I'm going to say direction equals image angle. See, we need a speed and a direction, and there we have it. If I could just put the order of letters in the correct way. There we go. There we go. So direction equals image angle. So there we go. If we're flying, slowly rotate towards the point where the mouse is, then we're going to change our speed. The speed at which the image index changes is 200. If we're pressing W, then go forward, increase speed in our direction that we want to go. Friction is 0. Otherwise, if we're not pushing W, if we're not pushing S also, then I want to slowly, enable friction and make sure we slowly stop and get to a hover position. It's the exact opposite if we're going in the other direction. So cool, that's all that's needed to fly around. It's pretty exciting. So over here, I'm going to now add another case, and this one's going to be called landing. Now, actually, in actual fact, you'll be pleased to know that flying has the most lines of code right over there. These other ones are, I'd say about 10 lines each. It's not too bad. So obviously image speed equals 100. And when we're landing, we are slowing down the blades, therefore decreasing the lift, and that's how we slowly land. If image x scale, to pay attention to this line, is greater than 0.5, this is to simulate the getting further away from us, so therefore it looks like it's landing. So image x scale minus equals 0.5. So this is the rate at which it gets smaller and smaller. And here we can say else state equals landed. Notice this right over here. So we started our image speed over here. It was 200, now it's 100. We've decreased the rate at which the image index changes. We are making sure that as long as we are greater than 0.5, as long as we're greater than half our start scale, the scale at which we imported the sprite, then we're going to decrease the scale by 0.005 every step until this condition fails, so it's no longer true, then it's going to go over here, boom, and say, oh, at this point in time, we are half of the size that we used to be, so obviously we must be landed, and if we landed, speed equals 0 also, because we don't want to move while we're landing. I've never seen a chopper move erratically while it's busy landing. I don't think that will end happily for anyone involved. So that's landing, it's pretty cool. Let's add another case, and this time we're going to be calling this one landed. Okay, so when we are landed, it means that our image speed is also, I'm going to set that also to 100. So I don't know if you'd really notice the difference between 100 and 200, but you might. It's just maybe one of those subconscious things that you can see, oh, it kind of looks like it's a little slower, because I'm landing, or because I am in a landed position. So I think that's all that's needed pretty much for landing. We just need to make sure that the image speed is set to 100. Obviously the enter changes the state, and if it changes it from landed to takeoff, which we still need to do now, then that'll have its own case right over here. Just make sure that we spell these things correctly, otherwise it will break. But not like a break statement, it'll actually just not work. So when we are taking off, our image speed is going to increase back to 200. We're going to do the opposite of what we did over here. So we're going from 0.5 to a 1, to full size of our chopper, or helicopter if you want to call it that, too. If image x scale is less than 1, here's the opposite. So if it's less than 1, then we need to keep increasing it. Yeah. Having a good day with typing. Image x scale plus equals 0.2. Notice this. There's a difference between taking off and landing. You see, what I've noticed with helicopters, and I'm no professional, when you land, you got to be very careful. Therefore, we land very slowly. But when we're taking off, it's very exciting. We still have to be kind of careful, but there's not so much of an obstacle involved with going up as there is when going down. So I've just assumed that you can take off a lot faster than you can landing. As you can see, that's quite a big difference. So that's cool. Otherwise, if we reach, if this fails, it means our image scale is 1. Then over here, simply state equals, not double equals, flying. Just like that. So we are now flying if our image scale is 1. Also, during takeoff, our speed is 0. You don't want to move while taking off. I mean, you can always change this and then just leave it out and see what happens. Yeah, mess around with it a bit. Make it your own. So there we go. That's all that we need there. We can close this off because those are the 4 states. Let's have a look. At the top, flying, landing, takeoff, and landed. Those are all 4 of the states. So at the bottom here, I'm also going to say image y scale equals image x scale. We're just going to constrain our scale right over there. So whatever the x scale is, because I don't want to say if image x scale is next to 1 and image y scale is less than 1, then do the same thing. That's just redundant. So here at the bottom, I'm setting one to the other. This is the one that we're editing, and we'll make sure it's set. This one's also set to the same value, so it keeps it the size. Cool. So that's all done. Right over there. So I'm going to say OK. Next, what I'm going to do is add a draw event, because we need to put in that shadow. And it needs to take all the kind of things that we've been doing now with the scale and whatnot, and it needs to simulate the shadow from a certain angle, what it'll look like as we are flying, or landing, or taking off, that kind of thing. And it also needs to take into account the speed, because we're taking off a lot faster than we are landing, and we're landing a lot slower than we are taking off. So here we go, we're going to put some code in the draw. Right over here, let's make this bigger. So I'm going to have a switch. It's going to take state again, very similar to the... You know what, let's cheat a little. I know nothing good can come from copy-paste coding. I know at first hand it can cause a lot of trouble, but right now I'm super lazy and I think I can handle it. I'm going to do this, I'm going to delete all this stuff, because we need these. Let's do that. Let's do that. Bam, there we've got a skeleton outline of what we need to do. So obviously we don't need flying, because that's just going to be set to whatever takeoff. When takeoff gets to the maximum takeoff, and then it goes to flying, obviously the shadow is going to stop moving further and further away from, to the bottom right of our sprites. Therefore, there's no point having flying over here. So in landing, I'm going to say shadow x and shadow y. Those are things we initialized before. Minus equals 1. 1 pixel. A rate of 1 pixel when we are landing. Do this. Copy, paste. When we are landed, then obviously they equal 0. You're not going to see that. It'll be under the helicopter. Also, that's a good thing when we are drawing our helicopter. We need to make sure that we do the right order. So during takeoff, I'm going to copy these again. Let's do some tabbing. Takeoff is going to plus equal by, I think it was 4, because we can take off 4 times faster than we can land. If you go back to our step, you'll see that the takeoff speed is, well, the rate at which the scale increases is 4 times that of the landing. So right, we've got 4, we've got 1, we've got 0. So if you're going to be changing the speed at which it takes off and lands, do note that you have to edit these with the same ratio. You've got to edit takeoff, you've got to edit landing, to make sure that it all flows and looks like it belongs. So do take note of that. So once that's done, here I'm going to do a draw sprite extended function. Let's see at the bottom, so we need the sprite. In this case, it's heli. Now, I'm not drawing the helicopter, I'm actually drawing the shadow. So as we go on here, sub-image is going to be image index. As we go along here, you'll notice that at the end, right here between color and alpha, those are going to be a lot different to if you were to use this function to draw the actual sprite as it is in your sprite resources. So x and y is going to be let's see, in this case we want it bottom right, so it's x plus shadow x and y plus shadow y. Basically, the plus and minus, that you can change to put the shadow in a different location with respect to your helicopter. Then our image x scale divided by 2, and our image y scale divided by 2, our image angle, and then over here, normally if you had to drag in draw self, which is this over here, let's go to draw, where are you, draw. If you had to drag in this draw self, it's basically just calling this draw function, right? Maybe not this one particularly, but it's calling a draw function, and then over here at the end, we're getting C white, which means no alterations to the color of the sprite we're drawing. But in this case, we want to make it C black, because we want it to be all like a shadow. And then also we want a 0.2 transparency, so it's only 20% visible. Okay, so you see that? Right over there. And then I'm going to cheat and just drag in this draw self. So that's going to draw the shadow, after which it's going to draw my helicopter, and because of the way the draw works, the things you draw first are going to be below the things you draw second. And then for fun, I'm going to add a draw GUI, just to show us what state we're in. So I'm going to just cycle through this really quickly. So there we are. We are drawing in white and whatever font I've chosen at these coordinates, the x, the y, and the state. So as that changes, you can see how it works. It's pretty cool stuff. So okay, we're going to go to our room. I'm going to zoom out, just go objects, place our helicopter, right there, wherever. Okay, so it's over there. You're going to go to views, scroll down here. Now these are all set before. So basically I'm going to tell it to follow the helicopter. We are going to have as you can see, this box, 128 by 720, that's going to be our width and height. We're going to port that to the same kind of box. The screen is going to scroll at 50, a rate of 50, and pixels between us and the border, us being the helicopter, is going to be 400 pixels. So as soon as we get closer than 400 pixels to the border, it's going to scroll at a rate of 50 per second, right over there. So let's say, okay, let's save this project. Hopefully it works first time, who knows, there might be some errors, we'll just see how it goes and fix them as they come. So hopefully this all works, let's test this out. Oh, so check this out, certain problems noticed. Yeah. We need to go back into the step and fix some stuff, because it's taken off way too fast. It's flying fine, notice the flying is fine, pretty cool. And it's slowing down if we reverse. Friction's taken over. So flying's good. Landing seems to be fine. We also need to fix the... Oh, look at that. The sprite of landing is opposite. Taking off is way too fast. So let's go back to our step and sort some stuff out. Okay, so we need to have a look at, let's enter. Yeah, well, we are flying with landing, so we need to go look at landing. I think takeoff was way too fast. Flying, let's see, let's zoom this out a little. I think it's F7. There we go, flying. Let's get more on the screen here. Landing. Landed, takeoff. Alright, so if you ask me, I think it's over here. This is crazy fast. 0.2 should be 0.02, or even less than that. As long as we keep the ratio between this and this constant. So as you can see, 0.05 is a quarter of 0.02. Right, so that was the problem. It was taken off way too rapidly. It was at full size within 5 steps, which is crazy. So that should sort out the takeoff. Let's say okay, save. Try this again. So here we are, we're taking off. Perfect, landing. Nice and slow. Look at the shadows lining up perfectly. Taking off, landing, taking off. We can do that at any stage. We can't move. We're not moving when we're landing. Can't move when we're taking off. Only when we are flying can we move. So your shadow X and Y is 101. That's fine. Right over there. It's very realistic. So if you found this tutorial educational and helpful, please feel free to comment, rate, and subscribe. Any problems, put them in the comments. If you like this tutorial as well as all my other ones, you can check out my Patreon campaign. Donate a few bucks, and I can carry on this channel indefinitely. I know, right? Pretty cool. So yeah, check that out. The links are in the description as well as the banners on the screen. Feel free to follow me on various social media networks. You got your Facebook, you got your Twitter, you got your Google Plus, all that kind of stuff that all the kids are into nowadays. Find all my updates and other stuff around the tech world right over there. You can download the project files straight in the description. They're going to have all kinds of comments helping you along. But yeah, as I said, if you have any questions, do put them in the comment section of this video and I can help you out, or someone else can too. So thanks for watching, stay tuned for more. Until next time, happy coding, and I'll see you then.